So the next topic here is the standard form. First of all, just focus on these three things that I've written over there. Why do we use standard form? What is standard form, and how do we use standard form? To give the answer of these questions, I'll elaborate this one first of all, the why thing. Why do we use the standard form? Well, the standard form is used to compress very big numbers or very small numbers. So if we have a huge number, let's say if you want to describe the distance from the earth to moon or something like that includes a biggest number, huge number, so you have to compress that to make a smaller thing. And similarly, if you have a very small number, and then for example the number of molecules or the number of cells in let's say human body or in something like that, whenever a very small amount is used, then you have to enlarge that. So that's the reason the standard form is used, to just compress the big or the small numbers to a special form. That's called that's the reason we use the standard form. The next thing it says, what is the standard form? So the standard form is a kind of a way where we write or we compress a thing in a way that should be between 1 and 10. That should be between 1 and 10, and this thing should be multiplied with a power of 10. So I'll just write this in a formal way. The formal way is that it should be 1, just writing x, that represents the value, the number, and okay, and the form would be x times 10 to the power n. So this should be a number between 1 and 10, including 1. So it might be 1, 1.1, 1.2, 1.07 until 10, but you don't have to include 10. It should be less than 10, and this thing should be multiplied with a power of 10. That power should be an integer, so can be a positive whole number or negative whole number, right? In short way. So yeah, that is the standard form. And then the next is, it says, how do we find the standard form? So that's the thing we have to explain. I have to explain this in this video. So let's begin with this. For example, I'll just pick a kind of random easy number. Let's say I have a number 5,000. Of course it's not that much biggest, but just to start the concept, I'll just give you the small number just to tell you. Okay, so what we have to do, we have to change this number 5,000 in this format, in something like x times 10 to the power of n. So what you can see, first of all, just leave the x thing, just check, is this whole thing between 1 and 10, or is it between 1 to 10? Of course no, not, because that's 5,000, that's more than that. So you have to keep this number within that. So to keep this number within that, you have to first of all change, or you have to find what is the power of 10 that is written over there. So if you just expand this number, you can write this in the form 5 times 1000, right? And now this can also be written as 5 times, now 1000 is the third power of 10. So this means this is 10 to the power of 3. Now if you compare this with the standard form, is this thing between 1 to 10? Yeah, that is. And there is a 10 power and there is a 10 power. So it means this is the standard form of 5,000. So that's the way you have to convert. Alright, so let me just give you one more example of the same type. Let's say if we have a number 200,000. And now you have to convert this into the standard form again. So first of all, just expand the number. So it means 2 times 100,000, and now it'll be 2 again times. What about this one? This is because this has 1 2 3 4 5 zeros, so this is the fifth power of 10. Now if you compare again, so this number is between 1 and 10 and there is a power of 10, so this is the standard form of that thing. One more, this time let me change it. Let's make it, for example, 37,000. Alright, so this number again means 37 times 1,000. 37 times 1,000 means 10 raised to the power 3. If you compare this again this time, so you can see 37 is 37 between 1 and 10. That's not actually, so because that's more than 10. So what you have to do, this is not the standard form yet, so you have to change this number, you have to make it smaller, further smaller than 10. So how you can make it smaller? The number is 37. So what you can do is you just have to use the operations of multiplication and division only to just make it less than 10, or even if you have something less than 1 even, I mean that doesn't come in this range, and if you want to make it more, then you have to times. So 37 you have to make it smaller, so what you can do, you can divide this with 10, and if you divide this with 10 you can clearly see this will be 3.7, right, because the decimal will just come out. So if you divide this with 10, and if you just remember the laws of algebra, if you have to divide something with a number, you also have to times that with the same number. So for example, if you have a number, let's say 5, and if you want to divide this with 8, so how you can times this thing with any number so that you should get the same answer again. So it was 5 in the question, you divided by 8, and it means you also have to times this with 8 so that you should get the answer back. So a kind of identity, or the inverse actually. Alright, so you have to change this number, so it means what you can do, you can just change this to 37, you have to divide by 10, and also you have to times by 10, and then this thing will remain as it is. Now if you combine all the 10s, if you just use the laws of indices, you can see 10, 10 and 10. So how many powers of 10 are multiplying? So 2 10s are multiplying, so the power is 3 and 1, so 4 10s, so 4 powers are multiplying, so this will be 10 to the power of 4. And what is the answer of this thing? Because if you do 37 divided by 10, if you divide them, you will get 3.7. So the answer of this whole thing, 37,000, is 3.7 times 10 to the power 4. And you can see, is this number between 1 and 10? Yeah, this is, and there is a power of 10. So there is also a short way. Let me just write this thing there. So it was, the number was 37,000. So basically what you have to do is to get the standard form, you can see right now the decimal is, I'll just change the color, the decimal right now is over there, right? And in the answer you have to make it smaller because that's bigger than 10, so you have to keep it between 1 and 10, means you have to bring the decimal all the way there. So what you can do, you can just check, if you bring the decimal all the way here, how many steps you have to move. You have to move 1 step, 2 steps, 3 steps and 4 steps, so it will be 10 raised to the power of 4. And then what is left over after you got the decimal there, you can see it's just 3.7000 or just 3.7. So that's your answer. Okay, let's do more on this. There we go. I have written some of the questions. Again, the standard form is you have to get a number between 1 to 10 and then you have to times it with a power of 10. So this is the pattern, or this is the standard form. Yeah, this is the original form to get the standard form. All right, let me just recall you again. So when we had 5,000, the answer was 5 times 10 raised to the power of 3, and then this was 2 times 10 raised to the power 5. If you just check directly, the decimal was there, so you just have to bring it 1, 2, 3. You have to make a number between 1 and 10, so you just have to bring it 3 times back. So you just brought it 3 times back. If you did from there, it will be 5 times. You have 3 more places ahead, so it's just positive 3 more places. Same is here if you do it here. The decimal is there, so if you bring it back 1, 2, 3, 4, 5, you can see this number over there is now between in the range of 1 and 10. So this number is 2. If you did from here, you can see it's just 5 more gaps on the right side, so we have 5 more positive powers. If you just repeat the same way now, so the next number over there is this, so the decimal is there. So you just have to bring it 1, 2, 3. Can we stop here? If we stop here, we'll get 18.2, and 18 is not in the range of 1 and 10. It means we have to make it one more step. So 1.8, yeah, that's 1.82 is in the range of that. So it will be 1.82. These zeros are just useless right after the decimal, so just disregard this. And then now if you read from here, you can see it just 1, 2, 3, 4 numbers after this, so it will be 10 raised to the power of 4. The same way, if you move forward further, this is 4,123,456,789. So that's the huge number. Again, we can check the decimal is here actually. So we have to go back 3 places, then 3 6, and then 3 9 places, because 4 point something would be in the range of 1 to 10. So it's just 3 6 and 9 places, or if we did from that side, this will be 4.123456789. 1 2 3 4 5 6 7 8. It's a kind of messy, but please never mind. All right, and then you can see if we read from here, we have 3 6 and 9 places after that, so it will be power 9 because it is on the right side. The decimal places are on the right side, so you have to just count the positive power. Further, next, this time it's already something with the decimal, so you just disregard that. Don't be this confused. Again, just do your normal way. This time the decimal is over there, but you have to make it, you have to bring it all the way 1 and 2 places over there, right? Because this will be then 3 point something between 1 and 10 if you just compare. So it means you have to bring the decimal 2 places. First of all, the new number will be 3.9708. I'm just writing the number now, 3.9708. And now from there, we just have to count how many decimals did we move. So we just moved 1 and 2 decimals, so it's power 2. The decimal in the question was there, we just had brought it 1 and 2 places back, so it's the same thing, 7.63295. And then we have 1 and 2 places moved, so it's 2 more places. Or you can see these both are the same numbers, so this can also be written as 7.63295 times 10 raised, if you combine them, so this will be 10 raised to the power of 5. And the last one, can you please pause the video and try this one out? What do you think? What did you notice? This question, what do you have to do? The decimal is there, so can you move the decimal on that side? If you move it there, it will be 0.982, and 0.9 doesn't really belong to this range. Can you move the decimal there? If you move it there, it will be 98.2, so 98 doesn't belong to this range. But if you check clearly, this is 9.8, so 9 point something means this is already in the range of 1 and 10. So this is already in the range, so we don't have to change it. And then you already have a power of 10, so it means this is already the standard form. So sometimes you can also get the questions that are already written in the standard form, so don't just change, it means the answer will be same thing. Now let's move forward to the opposites of this. All right. So if you check the first one, it is 0.08. If you check what is the place of 8 over there, so if we just go to the decimal concept, it's that is decimal, then you have tenth and you have hundredth, so it's 8 hundredths. 8 hundredths means you can also write 8 hundredths in this way, right? And then you are dividing 100, so dividing 100 means this thing is 8 times 10, because this thing is 10 to the power 2, but in the denominator or division means if you'll bring it up, it will change its symbol, so it's that. This time if you check, is this thing in the range of 1 and 10? Yeah, that comes between 1 and 10, so that's correct. And you have a power of 10. It doesn't matter whether it's positive or negative, as I told you before. This n should be an integer, so this is an integer. Yeah, so that's it. So in the same way, if you check this one, what's the place of 9? So you can see 10th, 100th and 1000th, so this is 9 out of 1000, or that means 1000 means 10 to the power 3 in the denominator, so that will be 10 to the power negative 3 in the numerator. So if you just check what is the pattern this time the whole thing is less than even this range, so this time is less, so you have to make it more. So make it more means you have to times this, so you have to bring the decimal over there, right? Then this will be 8. So this time you got 8, but now if you read from here, you have to go 1 and 2 places back means you have to put the negative symbol. Same is there, you just bring it there, then this number will be between 1 and 10, I mean that range, it will be 9. And now if you see from there, if you read, you have to go 1, 2 and 3 places back, so it's negative 3. Applying the same concept over there, you have to make it something between 1 and 10, so you just have to move it. Is it between 1 and 10? This is still 0 point something, so it's not. Is this thing between 1 and 10? This thing is 008.2 or just 8.275, so 8 point something is that's between the range, so it will be it will be 8.275, and then if you read from here, it's just 1 and 2 places back, so it's just negative 2. Next one, again if you repeat the same way, you have to decide where you have to bring the decimal, so that it should be between 1 and 10, so it should be there, right? So it means you have to bring it 1, 2, 3 and 4 places. So then the whole thing will be 0.00003 point something, or because these are just before the numbers, so useless, it'll be just 3.608 times. If you read from here, it will be 1, 2, 3 and 4 places back, so power negative 4. 2 more to go. Same way, if you have 0.08 there, even you can take the answer from there, but you just move it back, so it will be 8 times 2 places, so 10 raised to the power negative 2, and you already have one more power over there, so 10 raised to power minus 5. So again, if you use the laws of indices, these both are same numbers, so this will be, and they both are multiplying, so you have to add the powers. So what is 10, what is minus 2 plus minus 5? So that will be minus 7, so 10 raised to the power of negative 7. And the last one, again 0.08, so you have to move it there. It will be just 8 times 10 raised to power negative 2, and then we already have a power over there, so that's 10 raised to power 5. Again they both are 10s, same basis. If you use the laws of indices, it will be 8 times what is minus 2 plus 5? That's 3, so that's the answer.